Okay, so for our last question, we want the Lewis structure of acetylene and whether we expect the bond to be longer in C2H2 than C2H4. Compare the energies of the CC bonds in the two, and is it polar or nonpolar? So first, let's start by getting the Lewis structure. So for C2H2, you can quickly tell that this is going to be an alkyne that generally have the formula CnHn. And so let's just draw our general structure here. If we start by single bonds, that would imply more lone electrons on the carbons. Carbons love to make up to 4 bonds. That's why they're so great for organic chemistry. And if you count the valence electrons, would violate it, because we have 2 by 4 plus 2, which is going to be 10 electrons. And so we have 2, 4, 6, and we would need 8 more electrons on each of them, and that would be over our 10. So let's start with a double bond between the two carbons, because the hydrogens can't make any double bonds. And so again, the carbons are not yet happy. And if we add 2 electrons on each, that'll be 2, 4, 6, 8, 10, 12, which is over our 10. So let's fix this problem by adding another bond between these two. And we have 2, 4, 6, 8, 10. So everything is happy here. Formal charges. On carbon, you would have 4 minus 4, which is 0. And on hydrogen, you would have 1 minus 1, which would give us a 0. So everything is happy this way, and this is going to be our Lewis structure. Next up, we are asked whether the CC bond will be longer in C2H2 than C2H4. And so we need to talk about what dictates how long a bond is. And that actually goes back to the concept of the bond order, which is going to be the number of bonding electrons minus number of the anti-bonding electrons over 2, and this is involved in MO theory. But in organic chemistry, we can quickly see here that it forms a triple bond here, and so the bond order is going to be a high bond order. Then in the case of C2H4, which is just a double bond in between them rather than a triple bond. So this bond order is going to be higher than this bond order. And we know that the higher the bond order, that means the higher the bond energy, which would mean the shorter the bond length itself. So this means that the bond, since the bond order is higher in this case, that means the bond length will be shorter in this case because they have a higher energy, so they must be closer together. So the triple bond in acetylene is shorter than the double bond in ethene. And so the next question is compare the energies of the bonds. And so the energies we've already described here with the bond order. This is going to have a higher bond energy than this one because this has a higher bond order than this one. And lastly, we want to answer, is it polar or non-polar? This is a linear molecule, and you would have the dipoles pointing inwards, and thus they would both cancel out because the dipoles will be equal. In this case, the dipoles would look like this. And so they all cancel. This one cancels this, and this one cancels this. And so both are going to be non-polar. And those are your final answers.